All right, I want to do some more examples with this increasing, decreasing thing. First of all, let me remind you of the steps that we go through. First step is find the derivative and simplify the formula as much as possible. Okay, the second step, this is a little different from the way that I said it before. This little terminology here. Find the critical points. This is what's called the critical points. These are the points where the derivative is zero or when the derivative does not exist. Last time the example we did, all the examples we did had points where the derivative was zero. We actually didn't do this because it wasn't an issue in the examples we did, but today the examples are going to be a little more complicated, and you also need to find points when the derivative does not exist. And the reason you find these points are, these are the interval endpoints. All right, the last step is make a chart. Plug in points to see where f prime is positive or negative. That's what we did last time. So let's just try a couple of examples. These will be harder than they were last time. Okay, let's say where the function is increasing or decreasing. Give me intervals. For this function, f of x equals 2x minus 1 over x minus 5. All right, let's just get started. First step, take the derivative. So this is a fraction here. We're going to use the quotient rule. I go bottom times derivative of the top, which is 2, minus the top, times derivative of the bottom, which is 1, divided by the bottom squared. All right. Next step, this is still sort of step one, was take the derivative and then simplify. You'll have to do some business here to simplify the fraction, but it's not so hard. Let's distribute. Now combine stuff. All right, that's the derivative. Negative 9 over x minus 5 squared. Maybe I'll put that in a little box up here. All right, next step, find the critical points. These are the points where the derivative is 0 or where the derivative does not exist. So let's check the derivative equals 0 first, all right? To do that, you set this formula equal to 0 and then solve for x. All right, solve for x. Well, how do you solve when you have fractions in an equation like this? You want to do like a cross multiply thing or just multiply the denominator over to the right side. What that will say is negative 9 equals 0 times x minus 5 squared. But that's 0, isn't it? Negative 9 equals 0. We think about that, huh? Okay, this is false, right? Negative 9 does not, in fact, equal 0. What does that mean to you? It means actually everything that you wrote here must have been false. In particular, it means this first equation is not possible. That is to say, there is nowhere where the derivative equals 0. So my conclusion is f prime of x is never 0. All right? Okay. Are there any other critical points? Remember the critical numbers? The critical numbers, did I call them critical points before? They're called critical numbers also. Anyway, the critical numbers are the places where the derivative is 0 or where the derivative does not exist. So let's also look at that. F prime does not exist. Are there any places, any values of x which cause this thing to not exist? Well, what are we going to check? We need to check when the denominator is 0, right? That's what will cause a formula like this to not exist, is when the denominator is 0. Is it possible for the denominator to be 0? You bet it is. Well, the denominator is x minus 5 squared. So, I mean, you can kind of do this in your head, but when is it going to be the case that x minus 5 squared is 0? Well, you do that and solve for x. You could square root on both sides. It'll say x minus 5 equals 0, and then you add the 5, x equals 5, all right? So this right here is a critical number, all right? The critical numbers, remember, are the places where the derivative is 0 or the derivative does not exist, okay? So x equals 5 is what I'm going to put in my chart in the next step. Make a chart of the critical numbers, and then you plug in points on the interval. So the critical number we found was x equals 5. And at that point, when x is 5, the derivative does not exist, all right? Previous examples I had a bunch of zeros here. Usually the critical numbers are where the derivative is 0, but also it's possible for the derivative to not exist, and that will be a critical number. Anyway, as before, we got to plug in some point over here and some point over here and decide whether this thing is going to be positive or negative. So on the left of 5, let's choose 0. You can choose 4, I guess, but I like using 0 just because it's always easy to plug 0 into. You plug into the derivative. Remember, you plug into the derivative, not to the original function. Anyway, what's it going to be? It's going to be minus 9 over 0 minus 5 squared. And what is that? As usual, I don't really care what the number is. I care, is it positive or negative? Anyway, you can actually say what the number is without too much trouble. Negative 9 over 25, right? So this is negative. So right there, minus. And what about to the right of 5? Let's choose 6. F prime of 6 is negative 9 over, down here, 6 minus 5 squared. That would be 1 down there, right? Negative 9 over 1. So this is also negative, all right? And so what's your answer? We're done at this point, right? Whenever the thing is positive, it's increasing. When it's negative, it's decreasing. So my final answer is f, the function, is decreasing on the interval minus infinity to 5 and the interval 5 to infinity. So basically this is always decreasing except right here at that single point, x equal 5. All right. As always, you can check your answer by graphing this function on a computer or on a calculator. You'll see it looks like this actually. Here at x equal 5, you get an asymptote because of that 5 in the denominator there. And then otherwise the function looks like this. And I hope you will agree with me. It is always decreasing. It's decreasing over here, also decreasing over here. Except at just straight up at this point, the function doesn't even exist. So you shouldn't really say it's decreasing everywhere. It's decreasing everywhere except for at right at x equal 5. All right. Let's try another one. All right, here's another one. Give intervals where this function is increasing or decreasing. Fx equal x times e to the minus 3x. All right. What makes this one a little bit harder is just that you have to deal with this e thing, which is a little intimidating. It's actually not too difficult to work with. It's just you might feel a little weird about it. Don't worry, everything will be cool. One fact, let me just tell you a fact which we are going to use fairly often in problems involving e to the whatever, e to any power is always positive and never 0. All right, this is just a fact about e to the x because basically, well, there's a lot of reasons you could say this. If you look at a graph of e to the x, though, it looks like this. And what I just said is true. It's always positive. That is, it's up here. And it's never equal to 0. It approaches 0 as you go this way, but it's never equal to 0. All right. Anyway, let's go to it. Okay, step 1. Take the derivative and simplify as much as you can. All right, let's do it. How do you take the derivative here? Well, you got to remember your rules about e to the x, derivatives of e to the x. And also, I got x times e to the minus 3x. That's a product, so we got to use the product rule. So I say the first thing times the derivative of the second part. This is the chain rule, right? Derivative of e to the x is e to the x again. So you get the same thing again. And then I multiply by the derivative of the inside, which is negative 3. All right, and then plus, that was just the first part of the product rule. Second part of the product rule is the second function times the derivative of the first function, which is 1. All right? This is the derivative. Let's simplify as much as we can. This will make the following steps much easier. Simplify this. What can you do here? Not all that much, although I have two parts which are added together, and they both include this e to the minus 3x. So I'm going to factor that out. E to the minus 3x. And now what's left over is x times negative 3, which I'll write as negative 3x, and then plus 1. All right? This plus was right there. I just pulled that out. And then what remains is negative 3 times x plus 1. All right? This is a little tricky if you're a little shaky with your algebra, but that's how we do it. Okay, that's about as simplified as this is going to get. I suppose you could write 1 minus 3x if you prefer that way, but I don't care about that. Oh, I just wrote on my arm. Can you see that? Probably not. There it is. Next step, find the critical numbers. These are points where the derivative equals 0 or the derivative does not exist. Let's just talk about does not exist because there's not a lot to say about this. This is the derivative right here. This function always exists. There's no opportunity for the denominator to equal 0. That's one situation which a function fails to exist because there is no denominator here. Other situations would be square roots or logs of negative numbers. Not an issue in this case. All right, so f prime does not exist. Never happens. Let me just say f prime always exists. Basically, unless you see denominators which could equal 0, you don't really have to care about this. What we do have to care about is f prime equaling 0. This actually is possible over here. How do you figure that out? You just set up the equation, set it equal to 0. All right. And solve for x. Don't worry too much about this. It looks a little weird, but I have two things multiplied together, which equals 0. That means either the first one equals 0 or the second one equals 0. Okay. Or minus, I guess we don't really need those parentheses there, do we? I'm a lover of parentheses. I gotta restrain myself sometimes. All right. This one we can solve for x pretty easily, right? You add the 3x over there, so it says 1 equals 3x. Divide the 3x equals 1/3. Okay, how about this one? What do you say? You say, I don't know how to do that. Well, remember what I said before. E to any power is always positive. Never 0. This right here is not possible. So from this, we get no solutions. It is not possible to ever have e to something equals 0, all right? So this right here is the only critical number. That's what this means, all right? You don't get any critical numbers from this part, but you do from this part. X equals 1/3. All right, next step, make the chart, plug in some points. Okay, this is my chart. The only critical number is x equal 1/3, and at that point, the derivative is equal to 0. What else can we do here? We got to plug in something bigger than 1/3, something less than 1/3, and see what happens, all right? So I'm going to do f prime, let's say for something bigger than 1/3, let's choose 1. Go up here, e to the -3 times -3 times 1 plus 1, all right? Here's a moment when you might find yourself reaching for your calculator, right? We have to figure out, is this thing positive or negative? It's not necessary, though, to use your calculator. You know, on our tests and quizzes or whatever, I'm not going to let you use a calculator. You should not run screaming from the room. This is still possible to do. That's because of what I told you over here. E to any power is always positive and never 0. So what is e to the -3? Is it positive or negative? It is positive because I told you e to any power is always positive. So this part right there is positive. And what is this? This is -3 plus 1, which is -2, right? So this part right there is negative. So I have a positive times a negative, which is a negative. All right, that's what that is. So where was I? To the right of 1/3 is negative, like so. All right. How about over here? What value do you want to use that's less than 1/3? Let's use 0. I always like to use 0 when I can. E to the -3 times 0 times -3 times 0 plus 1. What's that? This is e to the 0 times 1, right? And what is e to the 0? Anything to the 0 is 1. So e to the 0 is 1 times 1 again is 1. And what do I care about that? It is positive. So I'll put a little plus sign right there. All right? 1 is positive. Okay, that's it really. What's my answer? I say f is increasing on the interval here, which would be -infinity to 1/3. And decreasing on the interval over here, 1/3 to infinity. There you go. That'll do it for today.